Welcome to the Periodic Table Foundation Part 3. If you have not watched the Periodic Table Basics Part 1 and the Periodic Table Foundation Part 2, then I really recommend that you go back and watch those before you do the Periodic Table Foundation Part 3, because those are what lead in to this one. So, if you have already watched those videos, then let's go on in and get started.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, pneumatium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
Today, you need to bring your thinking cap. A periodic table if you have one. If you don't, that's okay. I'll supply it as we move forward. Pencil and paper, and a lap book or a notebook. If you don't have any of these, we will still learn together. And remember to pause the video as we move along and then restart it. And I will tell you when you need to do that. So let's jump in and learn together. Our objectives today are to understand what causes atoms to bond together and how do valence electrons and bonding affect the properties of elements. This sounds a little bit different than the last two. That just means that we're moving forward in the periodic table, learning a little bit more. Are you ready? I am. Let's jump into learning. The periodic table. This looks very similar because we're going to use the same periodic table that we've been using with all of the same metals, non-metals, etc. You will need this periodic table, so make sure that when you pause your video, you come back and look at it. What information does the periodic table contain? We've been talking about this a lot. The periodic table is a chart of elements arranged according to the repeating patterns of their properties. Remember that elements have similar properties that are grouped together. How is the periodic table useful? Remember that the periodic table is arranged in 7 rows called periods. And have you ever heard of the Hindenburg? Hydrogen filled that airship in 1937. That sounds like a long time ago, doesn't it? But that information is extremely important to us. Remember that the Hindenburg had hydrogen on an airship. All right, we've learned that the Hindenburg had hydrogen, which is an element. Remember that hydrogen is in group 1. That means that it's extremely reactive, the most reactive element. So that made a dramatic explosion of the Hindenburg, which occurred when the hydrogen was ignited. And unfortunately, lots of people were killed on that. And Robert Boyle discovered the reaction between iron filings and dilute acids. This resulted in the production of hydrogen gas. Hydrogen was recognized as a discrete substance for the first time in London in 1766. Well, why does that really matter? The whole point is that the Hindenburg exploded in 1937 when hydrogen was ignited. So, the physical properties of hydrogen made the Hindenburg explode in 1937. So, hydrogen is in group 1 and it's very reactive. So just remember that hydrogen is in group 1 and it's extremely reactive, the most reactive chemicals. Okay, got it? All right, we're done. Let's practice. Based on the reactivity of elements, how would the result of the spark been different if the Hindenburg would have been filled with helium instead of hydrogen? Think about this. Pause the video, go back and look at the periodic table and look where helium is located versus where hydrogen is located. Pause the video and we'll go back and talk about it in just a minute. All right, helium is in group 18, all the way to the right. Hydrogen is in group 1, all the way to the left. So that means that hydrogen is much more reactive, much more explosive, and helium is much less reactive, much less explosive. So there's your answer. The Hindenburg might not have, or probably would not have, blown up if it would have been filled with helium. All right, let's move on. So, how is the periodic table useful? It tells us which groups are reactive, which ones have like properties. It tells us all kinds of things that are very, very important for everyday life. An element's properties can be predicted from its location on the periodic table. That's extremely important. Groups go down, periods go across. Okay. Metals. Metals are located on the left side of the periodic table and have physical properties that include luster, malleability, ductility, thermal conductivity, electrical conductivity, and they are solid at room temperature except for mercury. You know there's always an exception. Metals. Metals. Luster. Luster means shiny and reflective. Metals. Ductility is the ability to be drawn into thin wires. Metals. Malleability is the ability to be hammered or rolled into flat sheets, like coins. Metals. Electrical conductivity is the ability to carry an electric current. Metals. Thermal conductivity is the ability to transfer heat. Let's practice physical properties of metals. Luster means shiny and reflective. Malleability is the ability to be hammered or rolled into sheets. Ductility is the ability to be drawn into thin wires. Thermal conductivity is the ability to transfer heat. Electrical conductivity is the ability to carry electric current. Okay, it's your turn. Pause the video and do each of these. What means shiny and reflective? What means the ability to be hammered or rolled into sheets? What means the ability to be drawn into thin wires? What means the ability to transfer heat? And what means the ability to carry electric current? Okay, you're welcome to go back and look at the last slide, but try to do it yourself. Pause the video and come back when you're finished. Okay, if you got luster means shiny and reflective, you got it right. If you got malleability is the ability to be hammered or rolled into flat sheets, you got that one right. If you said ductility is the ability to be drawn into thin wires, you got that one right. If you said thermal conductivity is the ability to transfer heat, you got that one right. If you said electrical conductivity is the ability to carry electric current, you got that one right. You are awesome. I am so proud of you. We're going to talk about how metals are classified, talk about metalloids, non-metals, and so much other cool stuff. We're also going to move into compounds and even experiments in the next video and the video after that. We will learn more in our next video, so make sure you stay with us.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, then bismuth for your tummy,
polonium,
astatine would not be yummy,
radar,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens halogens and alkali react aggressively. Each period will see new outer shells with electrons are to the right.
Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, titanium, fermium, indolium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, meitnerium, dubsidium, rucenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson.
And then we're done.